Icaros, with the IDM 1000 that was presented, moved into energy audit in case of the waste of energy going into the heating and cooling of buildings. This describes here a project that was collected with the Icaros IDM 1000, and as you can see, was completely mapped at daytime with an RGB and collected at nighttime with the thermal complete oblique system, 5 camera oblique. What you can see here is a standard building, but we can see the energy that's being lost through the damaged insulation of the building. So we have the ability with the Icaros IDM 1000 to fly over any structure and collect the data in daytime and nighttime. And for nighttime flights, the temperature difference needs to be between day and night over 10 degrees Celsius or 16 degrees Fahrenheit. This allows to measure the performance in the winter time and the efficiency of all the buildings. Here is a perfect example. This was done in Maine in the winter time, and we can see that these buildings needs to have some repair. The loss of energy in this kind of building can go into thousands of dollars every year. Now, this kind of program allows also to prioritize what buildings needs to do what kind of a treatment, and then to monitor after the work is being done to verify that if we put new insulation, it really insulates it well and cut the cost of the energy. Icaros, from its early days, worked into developing a collection system and software to support application for the agriculture. Agriculture is one of the main sources of worry in the world because God doesn't create more fertile land, and every year the world needs more food. Food, in order to grow it, needs a lot of inputs that cost money and increase the cost. So we are looking into ways to minimize the inputs into the agriculture world, improve the yield, and save on the fertilizers, which are also cost a lot of money. In research in the universities around the world of Wageningen in Netherlands, Purdue University in the United States, and the Volcani Agriculture Institute in Israel, the research shows that by using optimal condition, we can save up to 70% of the inputs into agriculture. So just imagine that the food to grow it will cost 70% less, which means we'll be able to grow much food. And fertilizers are chemicals, and when we spread them over the field unintentionally, homogeneously, the chemicals are going into the water table, which means pollute the soil, pollute the water that we drink, and they are lost, which means we'll have to create and work more the next year. So here what we see is the use of the multispectral capability of the Icaros collection system, combination of the red, green, blue, or the multispectral bands in the visible and in the infrared, combined with the thermal to show stress in the field. And this stress shows where we have crop under non-optimal condition, and sometimes under condition, as you can see here, red and green, which is dried up, which means we have an irrigation issue. So the Icaros capability allows, with the processing that works automatically, cover the whole spectrum and allow deriving the anomalies. Analyzing the anomalies that we work on an automatic system to do it, will be able to help the farmer to produce much more with less. All this technology is going into the UAV, which means we'll be able to do autonomous system covering the multispectral field in an autonomous way. This will allow working the fields and produce much more food with much less resources. And here we go, all the different aspects that analyze the field and allows a farmer to know exactly what's going on in his field without really walking there. shows an example of water status. Optimal condition, an area that's saturated with water, and water stress. So in the same field, the variation of condition shows why we cannot grow the crop homogeneously. This is a project from UAVs where we are going now very much with developing smaller sensors. We look into the sugarcane, which is the largest produced in agriculture land-wise in the world. In Brazil, India, China, now going into Africa. Now sugarcane needs to be harvested 365 days a year, and the mills are producing 365 days a year. It goes to a height of more than 15 feet and unable to be penetrated into the field. How do we analyze? This is a sugarcane field that was flown with us in Brazil, and now we'll zoom in and see how we can measure the biomass and with the multispectral capability predict areas of anomalies, area that needs to be harvested, looking into optimizing the harvesting process with the ripening effect in sugarcane, because sugarcane is like wheat. We don't cut it, when it's coming into a certain color, but we need to harvest it when it's maximum sugar content. So this is being done in the research by some of the universities with multispectral capability. We look into the process that was done from an aerial system and measure the height of the crop in order to assess and estimate the biomass that we need to bring to the mill in the field. Thermal irrigation is another very important element that we can see from regular RGB visual that the field look to us with naked eyes to what's really happening when we are viewing it with a combination of multispectral with thermal.